still working? Okay. So back to pigtailing. Pigtailing is done normally with grounds, but sometimes you have to, if you have 3 wires running into something, you only have 2 screws to hook them to. You got a pigtail to reduce the amount of wires down, so you're only hooking 1 to it. So what pigtailing with a ground, and it would be the same for black or white, you take your ground wires and you're going to hook them together. But you also need a wire to hook to your device, whatever it be, a switch or an outlet or a light, whatever it is. So you put a chunk of that wire in there, okay? So, and you take a wire nut and you're going to just twist them together, okay? Now all of a sudden you took the 2 wires from your wires and you turned it into 1, okay? And this is what you would hook to your device. So then you would, if it was hooking to an outlet, you'd have to put a curl on there just the same, and that's what you would hook. Now with those pigtails, you had to leave 6 inches out of your box, correct? You also have to have this at least 6 inches long, your pigtail, by code. So from where it comes from the wire nut to the end has to be 6 inches. So you can't just use a little stub like this. They have to be color coordinated. If you're working with grounds, it has to be a ground wire. If you're pigtailing whites together for some reason, it has to have a white lead coming off from it. If it's black, it has to have a black lead coming off it. You can't start changing colors, okay? On to keeping with them wire nuts, there's different sizes of wire nuts. This one's for putting a whole bunch of wires together, or big wires. When you're working with 12 or 14, normally you're using brown or this tan or yellow. They're the same size, okay? Just different companies make them different. When you're working with, say you had 5 14s coming together, they wouldn't fit in a brown or a tan or a yellow. You have to jump up to a red's the next size, okay? But you don't use these when you don't have to. If you got 2 or 3 14 wires, you don't use red, you use tan or yellow. Same now with 12 wire, because it's a little bit bigger diameter, probably when you got 4 of them hooking together, you would have to use a red. But 3 of them could still work in the tan, okay? So we went over pigtailing and why you have to pigtail. No questions with that. I just want to jump back a little bit because I didn't have them nail plates. What an inspector will do, or you would want to do, say, there's some situations where you can't get that hole in the center. It's just the way the wood is and you can't get in there. What you have to do then, by them holes, is pound these nail plates in. And what that keeps from happening is when it's drywalled or whatever's covering the wall, if a screw or a nail hits at it, this keeps bending it. It won't let you go in there. Then there's no chance you're going to nick that wire with that. Okay, you have to put these in. These come in different sizes, lengths. They're also used for plumbing, you know, to protect plumbing in a wall, so that don't get a screw in it. Same thing, you have to have them in the center. I want to skip back a little bit to those breakers. This is a 30 amp breaker, but this is called a double pole. It's a 240 breaker, okay? It pulls off two things. If you look at a panel, this is your main breaker, okay? This turns, this bar here is hot and this bar here is hot, okay? You have 120 coming into both sides of this. 120 here, 120 here. When you hook up a 240 breaker, if you look at how these lugs are set up, if I'm to clip this in here, this clips onto that and then they fold in. It's pulling off this bar and this bar. It's pulling this one comes from this side, this one comes from this side. So it's pulling off both sides, and that's how you get 240, okay? That would be, this is a 30 amp. This 30 amp, a hot water heater has to be, electric hot water heater has to be on 30 amp. or electric dryer has to be on a 30 amp, okay? Couple of things. An air conditioning unit has to be on a 30 amp double pole, okay? We already talked about these. Now these are just single pole breakers. It's 15 amp for outlets. You out of here? Okay, you'll just have to catch up with the, okay. And then 20 amp, okay? So 20 amps for what size wire do you use? What is 14? 14 is for what amp breaker? 15. Got to know that. 15 amp breaker is 14. 20 amp breaker is 12 wire. And what's 30? 10, yes. Okay. So just a little bit back, I did pull some fuses out, a few different types. This type of fuse here, some of you may have these in your house or have seen these before. These are a one-time deal. They break, you got to thread a new one in. These are called Edison-based fuse because it's the exact same as a light bulb. And that's kind of weird, isn't it? That they put the same threads on it. But this is a 15 amp. You can get these in different amperage. This is a little bit different type. I'm not quite sure what these are actually called, but they got a smaller base. So they work the same. These are other types of fuses that's used for different things. They clamp in different ways depending on the box that they're going in. But they work the same way. They blow. Some are delayed fuse, some are break right away. This depends on what you're using them for. Real quick, back to the panel. Whenever you have a metal box, this is considered a metal box, this would be considered a metal box. Whenever a wire comes into these, you can see, any of you ever punched any of these out and they kind of look like a coin, the knockouts they're called, or seen them laying around. You can't just run a wire through that knockout, okay? You have to use what's called a Romex connector, and I have one here. This is a 1/2-inch Romex connector. They go on like this. You tighten the nut down here, and then your wire runs through that. And it has these 2 screws here where you can tighten down on the wire. You have to have, whenever it's a metal box, it has to have either a Romex connector or something that tightens down on the wire. Can't just be running in a hole. So this type here has a clamp built in. So you would knock one of these knockouts, run your wire in, then tighten that down, and that would tighten down on the wire. That works also. It also has knockouts, and some of them don't have these at all. You have to use a Romex connector on them. Can lighting, this skipping over to this here, same thing, has a box here with knockouts. You can't just run the wire in this. It has to have a Romex connector to tighten down on the wire. Now that allows you to staple farther away from a metal box. Because it has to have something that clamps down on the wire, your first staple can be 10 inches away from a metal box, where a plastic box is maximum 6. So that changes that a little bit. Just some different type of plugs. I don't think I really need to go over them right now. Different types of entrance wire. I did want to kind of talk about that. Of course, this comes in all different sizes. This is really big wire. This probably ran to something commercial, I'm sure. You wouldn't see this in residential more than likely. But there's 2 different types of wire here. One's aluminum and one's copper, okay? If I had to run this size copper right here, because that's what the requirement was, whatever I was livening up, if I was using aluminum, the aluminum would probably be about this big around, okay? That's one thing nice about using copper. The wire is smaller. You can run a lot more power through a smaller copper wire. Aluminum has to be bigger. That's all determined by the size of the wire and what amperage you're running, okay? This is pretty small, probably for 100 amp service. This comes in aught sizes is what this is determined by, like 1 aught, 2 aught, 3 aught. when you're using aluminum, or if you're hooking to aluminum lugs, which these are, that would be where your main power comes in, 120 on each side. This wire would come in, of course, through conduit and hook here. You have to coat that because aluminum oxidizes and you'll lose power if you don't. There's a special treatment that you have to put on the wire after you strip it. Before you hook it to that, you got to put this crap on there. It looks like grease. You have to use that. Even though this is copper, you should still put it on this wire because this is aluminum and it would oxidize. So if you don't do that. Better look over my notes and see where I am, make sure I'm covering everything I wanted to cover. So staples have to go in the center of the stud, holes have to get drilled in the center of the stud. Clockwise pigtailing sticking out. Oh, I knew there was something else I wanted to grab out of that cabinet and I didn't. Just want to show you guys a little bit. There's a lot of different testing equipment. Each of you should have a tester like this that you can test a lot of things with. This will not test everything we need to test. There's also this, and there's these. These are really nice when you plug them in a receptacle. They'll tell you if it's wired right by according to how the lights are, and you guys will use these to test your own projects. It's just got a series of different lights, how they light up. It tells you what's wrong, okay? So you guys are gonna have to sort your own electrical problems out. One big thing that happens in here is people, have you ever heard of continuity? This tells you if a wire makes a complete loop. Well, that's what a bulb does. It makes a complete loop here. Sometimes people don't know if they've got a wiring problem or if the bulb's bad. And I just want to show you how to check something with continuity. You can set this particular one, it'll make a sound if it's making good continuity, and that's that symbol. It looks like a horn or something. All these are basically the same. So, hear that? I know that air's going, but can you hear that buzzing? That tells you there's good continuity, but I'm not really going through anything. To check a bulb, same thing. You can hold one of these on the tip of it, one on the side, and it should make that beeping sound, but it's not. That tells me this bulb's probably bad. A fuse will check the same way. That fuse is good, okay? So it's really hard. That's not glass. You can't tell when this blows. But that's how you would have to test it. Same way with these, you can check them. So here to here, that one's good, okay? It won't make that sound if it's not making that continuous loop, okay? So you may have to do some testing that way. If you use these, make sure you shut them to off because it deadens the battery. You can also test other things with this. I don't really like to use these to test with power until I've really went over it good with you, because if you hook this up wrong, if it's on the wrong switch, it burns a fuse out in here, and those fuses, you might as well buy a new one of these before you replace the fuse. So I don't want to blow those. So this is for just checking 120. This you can check, on this particular one, you can check 120 or 240. On yours, I don't think you can check 240. You could check them individually, but not together. So I won't even go through that today. I guess that's probably enough information to get you guys going on your project. What I have to start out, I want you to practice some of the stuff that we talked about. So I got a step-by-step directions that I want you to do, and that's what you're going to work on these walls, okay? I do not want you to get my new boxes out for this. I want you to use old ones because it's rough on the nails. Something else I didn't talk about that I do want to talk about. When you do remove a box, you got to be careful because you bend them nails all up. I don't want you using this and you claw your hammer. Use a flat bar and get in there and work it out slow, okay, and work the bottom out slow so you don't bend those nails up. If you bend them up a little bit, take your linesman's pliers and straighten them out so we can reuse them, okay? Don't just yank those things off there because you screw the boxes all up. Removing a staple. Sometimes you may wire something wrong and I'll make you change it. Linesman's pliers work really good, or not needle nose. Don't drive a screwdriver in here because you'll nick the wire, okay? But if you grab that staple with your linesman's plier and you pinch real hard and then you pry against your wood, you can pull that staple out. Usually you don't even damage the staple, okay? Sometimes you do, but that's how you want to remove them, okay? I guess that's all I have for today, and we'll go over some more probably tomorrow. So,
Tomorrow?
or Monday. Well, if you want to come in. Huh?